So we start off with just the review of what we did already. There's the properties you can see here. Let me get this. There we go. There we go. There's our properties that we learned. They're all based upon the exponent rules. So when you're multiplying the same base, you add the exponents. That's why the multiplication and the addition go together. And when you're dividing, you subtract the exponents. Remember, each of these is an exponent. The answer to a logarithm is an exponent. So they're just saying when you divide two of the same base, you subtract those exponents, right? So it's good to link those together so it makes sense, and it's not just something you have to memorize and that's just the rule, but it should make some sense of why it actually works, right? Same thing here. This is saying, this base to what power, right? It's basically saying this base to what power equals this part, b to the k. All right, so of course it should just equal k. That's why it equals k. It's a little more abstract, but still makes some sense there. Okay. Now we have something kind of when logarithms, you can use any certain base, but we use 10 as called the common base or the common log. Right? So I think I mentioned this before. If there's no number here, right, it's automatically 10. And if you use the log button on a calculator, it's automatically 10. Right? Now some calculators, as I mentioned, don't have this button where you can put in a different base. So like this one actually has it in there, right? So I can say, well, what's log of 8 base 2? Or 2 to what power equals 8? I can hit that and I get an answer of 3. Whereas some of the other calculators, if you have like the TI-30 or something like that, you don't have this button. So there's a way of getting the answer or changing the base to 10 or the natural log and to get you the answer. So we'll talk about that today. But let's just first play with this a little bit and make sure we understand what we're doing. So go ahead and type in, if you haven't already, what is the log of 100? So if I go here, log of 100, right? And you should know the answer to this, right? What is the log of 100 if the base is 10? Yeah, 2. So you already have an idea. Okay, answer is 2. And you'll notice I already have it set because the direction said 3 decimal places. So on your calculator, do you know how to go into the mode and change it to 3 decimal places? So I can change mine to say, give me my answer 3 decimal places. That way in the middle of your math analysis pre-calculus problems, you're not missing or getting the wrong answer because of 4th grade rounding. Right? So the more you know how to use your calculator and know how to change the settings to optimize everything, the better for you. Right? Obviously you can always round everything manually, but it's frustrating to get a not perfect score or get a B plus and you're like, you mean if I just did rounding correctly, I would have had an A? Yeah. It's like, so, every calculator you can do this, you can change the rounding, in some way. So learning how to do that could make the difference. So same thing here. We have 10 to what power is 35? Now, obviously you know that 10 to the first power equals 10. And 10 to the second power equals 100. Right? And 35 is in the middle of these. So you know that the answer should be 1 point something. So I want you to have some intuition about what the answer should be. And it's not just, well, I'll get the decimal from the calculator and who knows what it could be. We should have some at least idea of, around what the answer should be. So if I go ahead and type in what is the logarithm of 35, it says 1.54. As we thought, it's something between 1 and 2. 1.544. Okay. For number 2, what do you know about the answer right away? What will it have on there for sure? Because this is a decimal, aka fraction. It's a negative, right? So we should look at this and say, well, 2 tenths, that's 2 over 10, by the way, 2 tenths, it's in the tenths place. That's the same as logarithm of 1/5. You know fractions are negative exponents, so right away we already know the answer is negative. All right. Now you could put in log of 0.2, or you could put in 1/5. It doesn't matter. I'll give you the same answer. But again, just talking about the intuition of it, right? Should look at that and know ahead of time that's a negative answer. So we got 0.699. There you go. And you can do checks on these. So each one of these you can check. So if I wanted to check this, I could say in the calculator, what is 10 to the 1.44 power? All right, see what it comes out to. Same thing here. All right, so there's always a check. All right, and this should be something close. It'll be close to 35. All right, that's for this problem, by the way. And then over here, I could say, well, what is 10 to this power? And negative 0.699. And that should be somewhere close to 0.2. So on your quiz, it should be like an automatic. It's a calculator problem to start off with, but there's also a way to check your answer. So hopefully these are give me questions, when you're going through and doing your actual assessments. All right, so we got base 10. Right? That's called the common log, right? So there's another base, which is this transcendental number, also known as the natural number e. Okay? And this is very similar to pi in how it's found in nature. It's a very, that's why it's called the natural number, right? And there's all sorts of high-level, applications from, just complex mathematics to finance to nature to so many things, which if you go into higher math, you see this number all the time, even more often than the number pi, right? You'll see this natural number e, okay? Its approximate value is 2.718. So you want to equate this like, okay, pi is about, 3.14. You want to memorize, okay, e is about, 2.718. If you want to know exactly, more decimal places, there is an e button somewhere on your calculator, right? And you can find it like this one. I just have, if I press it once, it gives me pi, right? Get the decimal there. But if I press it a few times, I get e. So it's an irrational transcendental number, just like pi. And it has its own, because of it, and we have to do a lot of solving with e, problems with e in it, it has something called this natural log. So if we have a base of e, right, we switch it to natural log, this ln. So you think of ln as a logarithm, but the natural number. So that's why it's ln. Logarithm natural. So we'll use this one anytime you have an equation that involves the number e, right, or a base e. So you'll see equations that have an e in it. That's the sign that you need to use this ln function as opposed to the regular log function, which is base 10. And we'll look at both today. Okay. All right, so these just say write them into a equivalent form, an exponential or logarithm. So this is in the exponential, which means let's write this in logarithm form. E to the x equals 4. E to what power equals 4? Remember, this is 2.71, to what power equals 4. So we want to think about it is that we're like taking, since it's e, we're taking the natural log on both sides. So we have the natural log of e to the x equals the natural log of 4. And we have an exponent property that says if I have an exponent here, ooh, that's not what I thought it was. Okay. If I have an exponent here, I can bring it down in front. And I'm showing the long version of this on purpose just to show it how it comes out. So now I have natural log of e equals natural log of 4. And since this natural log has base e, remember if these two numbers are the same, it just equals 1. So this is how I just get x equals times 1 is natural log of 4. And that would be the logarithm way of looking at this. In the future, you can kind of cut out the middle part and just go straight to here, but I'm just showing it how it actually works on this first one. So that's the exponential, because it has the e in there, converted to the logarithm. This is logarithm, and we can convert that to the exponential. So if I have natural log, that means I'm going to have that new number e involved. Right? The answer is always the exponent. Right? So equals some number, that's the exponent. So all this is saying e to the 0 power equals 1, just like anything else to the 0 power equals 1. Okay. So the same old thing we did on the first day of logarithms, we were just converting back and forth between log form and exponential form, doing the same thing here, but using this new logarithm called natural log. Okay. So go ahead and do 1 and 2. You don't need to solve it unless you want to keep on going through and solve it, but just convert it to the other format. So this one is in the logarithm format, converted to exponential. This one's an exponential, right? Converted to log format, which means number 1 will have an e to some power, and number 2 will have an ln in its final answer. Should come up with these two right here. And if we wanted to solve number 2, we could add 1 to both sides and put it in the calculator and get a decimal, but we're just practicing converting here, and that's it. Okay, so simple enough. Same rule we used before, we just got this new number e, and we got these ln's to add to our repertoire. Alright. So I started off by showing you about the different buttons, right? And that, like this calculator, you could actually press it 3 times and you can actually put the base in there. So I can actually do this problem right here, log of 42 base 3, or 3 to what power equals 42, right? I can put it in there. But some of you might have a calculator that does not have this button. So the question is, well, how would you get that same decimal without having this button? So that's what this is all about. What you do is just make it a fraction. This number right here will go on the top, right here. And the base here will be its own log down on the bottom. So that will go down to the bottom right here. And then we can switch the actual base to anything we want. Right? You'll get the same answer regardless. That's the cool thing about this. So something like this, again, it's just a fraction. I can rewrite it as a fraction, where we have log of this number on top. So we'll have log of 42. And then on the bottom, that'll be this number, the base log of 3. So on your calculator, if you didn't have this button, now you can just use the regular log button and go ahead and practice this right now. All right, we got log of 42 and divided by log of 3. And you notice it comes out to the same exact decimal. And it says here base 2. All right, base 2. So technically, if we didn't right now I use a calculator. I didn't put a base in there, so I use base 10. You notice how I got the same answer, but it could be base 2 as well. So as long as these are matching, you'll get the same exact answer. So this one, it says what base, it could be anything, and that's what's the most important part. Okay, so while it's 2 here, you wouldn't really do that on a real problem. You just leave it as base 10 and use the regular log buttons. Okay. And same thing on this one. This one's base 10, so it's more like all you gotta do is say this number goes on the top, that number goes on the bottom. So this one will be log of 23 divided by the log of 2. And technically it's base 10, but we don't really need to write the 10 there, right? Because it's assumed it's base 10 without writing, without writing it. If you did, it's not wrong, but it's kind of like writing, 1x equals, 5 as your answer. Well, it's assumed it's 1x. We just write x equals 5 as the answer, right? Same thing here. It's assumed it's 10 if there's nothing there, right? So whether you want to or not, it's okay. So that's called the change of base. We can rewrite any logarithm and any base to something else that's more convenient or needed. And for the most part, it's just to base 10, so you can use the calculator if you don't happen to have this button, once again, that includes the base and the result. So a lot of little things on the front. Okay. Again, get familiar with your calculator. Use the same calculator for your homework, for your tests. Do not use a phone calculator for anything in this class, because then you switch over to the quiz and you're picking up the calculator the first time and you have no clue how to use it. And I'm not going to stop and teach you how to do it during a quiz. You're not going to get more time because you didn't practice using the real calculator during your homework. So do make sure you practice. Okay. All right. So let's flip it on over and we'll be done in a jiffy. Give you time to work. Maybe get your homework done for the weekend. We keep on moving.